Hello, my name is Eduardo Zarate, and I'll show you how to do a birthday polynomial using your date of birth. For this project, it will be more beneficial for us if we break it into three different segments. Objectives, analysis, and interpretation. Our objective will see the challenge of how we make this polynomial fulfill the question. Analysis. We'll see how our values fluctuates between the y and the x-axis based on what we provide. In interpretations, given a specific value, how does the graph moves across the x and the y-axis and how it interprets into our lives. Objective. Develop a polynomial function with interesting slope and turning points by using your date of birth. Graph the polynomial that expresses your daily activities. You can base your polynomial to measure different types of factors: energy flow, activities, or how much you just eat a day. Let's start analyzing a project. Personally, my birthday was on April 6, 1993. The first thing we must do is flip the digits from left to right. Now, I was born in 1993. That was the year that I was born. So I must start first with the furthest to the left. There will be a 3, then a 9, another 9, and a 1. That should conclude the year I was born. Then let's move on to the actual date of when I was born. I was born on April 6. So that means that I will have to cancel the 0 because I want to put an x instead of that. So then I will use the 6, and then I will use the 4th, which is the actual one when I was born. Remember, we must cancel the zeros so we can put a value of x. Making our personal polynomial. My numbers are, one more time, 399,164. To create a polynomial, you will need to add exponents after the x values. In this case, we'll decrease the amount of exponents based on our total amount of digits that we have in your equation. As you can see, in this case, I have f of x, 3x to the 6, 9x to the 5, plus 9x to the 4th, plus 3x to the 3, 6x to the 2nd, and x as 4, because I want to have a remainder of no exponents of 1. My personal polynomial. Right in front of you, you'll see the actual equation that I came out with based on my date of birth. I've chosen the pattern between plus and minuses so the graph can fluctuate the actual activities that I do daily. One of it is when I start in the morning. I have a lot of energy. So the first point that the graph shows is very high. That's the energy when I just woke up out of bed. Right after, I go to school, so I wanted to make sure that my energy will be slowly decreasing. As I go through school, it will be probably mentally energy that I actually use, so I can go through that period of time. After that, I have to take a snack or two. That should actually give me some energy. I wanted for my graph to actually show the actual energy going up, so I had to change a plus or minus between there. After that, it gets to the middle of the day, especially when it's the core of my day. There is where I have to go work and put majority of the energy where I actually have to use. After that, I wanted to have a dinner. Always have a dinner after work. So I wanted my graph to actually show my regaining of energy to take me to the position where I just going to start the next day. So this is what I did. I started with a high number, I went down with my lower number, then I went high again, and I wanted my graph to slowly and surely go little by little all the way to reach to the minimum point. And then after I have dinner at that time, to increase. To know that you successfully created a polynomial, you need to look for these behaviors in your graph. A solution of set of real numbers. How many times has your graph crossed the x-axis through the graph? Those are real numbers. A maximum. What is the highest number that the graph shows? Your minimum. What is the lowest number that your graph shows? And a description of behavior. Does the graph goes back to the starting point, or does it goes higher at the end of the points? As an example of my real numbers, I have 4 dots on my graph. They're highlighted in blue. Those are the times that my graph crosses the x-axis back and forth. Those you can count as real numbers or solutions. My maximum. What is the highest number of my graph when it crosses the x-axis and goes into the y-axis? The highest number, per se, in this option. My minimum. The lowest number crossing the y-axis, the lowest value. And my description of end behavior. Thus my graph goes back to the high number after it has crossed the positive y-axis. Interpretation of values. The last segment of our project. This is where you have to provide a value to every single dependent and independent variable. For me, I've chosen to provide energy flow as my dependent variable over time. Why? Because depending on how much time I do every single activity, it depends on my energy flow that I will have for the day. As you can see in this graph, I have from going to sleep to college, which decreases my actual energy flow, back to normal when it goes into when I have lunch, which decreases my energy flow, going back to work, which decreases, and going back to bed in the night, which increases back my energy flow. Those could be my dependent and independent variables in this polynomial.